All right, so back to where we just left off, where you have just been working on your transformations and now testing to see if you were right. All right, so okay, so first you said you have a vertical stretch by a factor of 4, and then this 2 means that there's actually a horizontal compression by a factor of 2. This 5 on the inside is again horizontal, so that's a horizontal shift. Sorry. And it's a horizontal shift that says x plus 5, so that actually means that we're going to move left by 5. Okay, so in the negative 5 direction. And now this 8 on the end is your C value, and that is a vertical transformation, so we're going to put that in red. So this is a vertical shift, by, so we're going down by 8 because 8 is negative. Okay, hopefully you can read the shorthand story. It's the best I can do with the materials I have right now. Okay, so if you chose the harder version, good for you. Good job on the challenge. Okay, so the first thing that you would have seen reading left to right is this negative out front. So anytime you're trying to just look at this equation and figure out what transformations have happened, you'll start by looking on the left first, and the most left thing here is this -1. And that -1 means that we have a vertical reflection. So vertical reflection, so a reflection in the x-axis, so flipping upside down. Now this 1/3 is the rest of your A value. That's going to cause a vertical compression, and it's a compression, not a stretch, because it's a small A value. So it's a value between -1 and 1. So it's a compression by a factor of 3. So that means it's getting 3 times smaller. So compression by a factor of 3. So hopefully you remember all that stuff from last year. It says 1/3, but you say compression by 3. We can go over that part tomorrow. I know that's confusing for some of you. Okay, so the next thing, reading left to right, is this negative on the inside, and that negative is a horizontal reflection. So H reflection is all I'm going to write. Oh, that's supposed to be RE, sorry. Reflection, I'll redo that R. Horizontal reflection. And that's by a factor of 5/3. I know that's confusing. We'll go over that part tomorrow. It's just too hard for me to explain over video. Okay, so that's a horizontal compression, a horizontal reflection, and then also a stretch by 5/3. And again, I'm writing it in blue because it is horizontal, just to distinguish that for you visually. Okay, next is this -2 that's also a horizontal change. So that's actually horizontal shift. So horizontal shift, and we're going to move right by 2. Even though it says -2, we're actually going to move right, so in the positive direction by 2. And then lastly, we have that 1 on the end, which is the C value. So that's going to be a vertical shift up by 1. Today is a day where I really test your patience as a teacher. I'm really sorry. This will get better. Okay. So hopefully you did well on whichever one of those that you chose. Okay, so now what we're going to be doing is combining this idea of transformations with our function notation f of x. So let's say we're looking at something as simple as f of x equals x squared. So I'm going to graph that. So we know that's our most basic parabola. So if f of x is x squared, then if x is 0, then f of x is also 0. If x is 1, then that's 1 squared would be 1. And if x is -1, f of x would be +1 as well, because -1 times -1 is +1. If x was 2, then f of x would be 4. If x was -2, then f of x would also be 4. So just making our parabola. As well, you could do this by looking at your step pattern. So you plot your vertex, you go over 1, up 1, over 1, up 3, over 1, up 5. Or you could observe that, oh, okay, when x is 3, then y is going to be 9. And when x is -3, y is going to be 9. So whichever way you want to graph that, whatever. Hopefully you're really familiar with y equals x squared, because it's pretty important, and you've been looking at it for a while now. Okay, so that's roughly what f of x equals x squared looks like. So now if we were asked to graph the function f at x minus 2, that's actually going to cause a change, a transformation, in the same way that we would see before. So ask yourself right now, is that an A change, so is 2 A value, or is 2 the K value, or is 2 the D value, or is 2 the C value? So I'll give you a sec just to think about that. Is it A, K, D, or C? What role is this one playing? Okay, hopefully you can see that it's a D value. It's a number that's being added or subtracted to X, and that's kind of the role that D plays. So that would basically, oh, sorry, I'll back it up. So that basically means that we're going to have a horizontal change. I'll leave it just for a sec. That it's going to take our whole parabola and it's going to move it right by 2, okay, because I can see that that's D. Now, the next one we're going to be asked about is f of x minus 2. So I want you to think about for a sec. F of x minus 2, is that A, K, D, or C? What is the minus 2 doing? Is it A, K, D, or C? It's probably not D because I just told you that this one is D. So A, K, or C? All right, hopefully you've concluded that that is C. If you have, you are right. Okay, so the D value looks like this. So f at x minus 2 means that we're taking x squared, but we're moving it left by 2. So it's gonna, our equation is going to look like this, where we can see the d. So the x with the d all being squared. So let's graph that. Okay, so that means that our whole function, which is just y equals x squared, because this is a negative 2 in here, it's actually going to move our whole function right by 2. So the vertex is now going to be over here. And this point is going to be 2 away from where it currently is. And this point is going to be 2 away from where it currently is. This point is going to be 2 away from where it currently is in the regular function, the parent function. Same thing with this one. This one I'm going to move over by 2. And this one I'm going to move over by 2. Okay, so now when I connect the dots, hopefully it seems really apparent to you that our whole graph has just moved over by 2. Cool, voila. Okay, now let's look at the green one. So we decided that this was a C value. So our equation is going to look like this, where we have, this is our x squared, which is just the regular f of x, but that f of x has been reduced by 2, so the whole thing is going to move down by 2. Okay, so from where our vertex was originally, the whole thing is going to move down by 2. This point is going to move down by 2. This one down by 2. This one down by 2. This one down by 2. Everything is just going to move down by 2. If you wanted, you could just move your vertex and then do your step pattern, since there's no stretch or anything, so there's no change to your step pattern. So anyway, hopefully you can see that the green function is the same as the black except moved down by 2. And that's what this is telling us to do. Cool. Okay, next little topic is this idea of having a function of another function. So, okay, this is a little bit tricky, but really it's quite simple if you just kind of can wrap your head around it. So, all right, here it says f of x is, I'm telling you, x squared. Okay, so I'm just stating this is what some function is, its value is x squared. So if g of x is equal to x squared but minus 5, then how could we express g of x in terms of f of x? So how could we use f of x to talk about g of x? Well, since f of x is x squared, and here's an x squared in g of x, then we can rewrite this so that instead of writing x squared, we're actually writing f of x. So it would look like this. It would be g of x equals, instead of saying x squared minus 5, since x squared is equal to f of x, then I'm going to write f of x here. So I could say g of x equals x squared minus 5, or I could say g of x equals f of x minus 5. So hopefully this is seeming kind of familiar to you based on what we did on our last quiz, where we were putting functions and function notation and then adding numbers and multiplying numbers. So this is this idea where you can have a function of a function. This is sort of a precursor to what you're going to talk about next year in advanced functions with composite functions and stuff. Okay, here's another one similar to that. I'm going to change my color because that color was a little too light for me. All right, let's go with pink. Okay, if h of x is x and m of x is 2x, then how could we express m of x in terms of h of x? Well, same thing. So here we have h of x is equal to x. And look, here's an x. So instead of writing x, we could write h of x, since x and h of x are equal. So if I'm going to write m of x, I'm going to express m of x, but in a different way, I could write it like this. I could say m of x equals 2 times x, but instead of saying x, I can find something that's equivalent to x, which, is h of x. So I can rewrite m of x as 2 times h of x. So notice this does not mean 2 times h times x. It means 2 times h of x, where h of x is the whole function. Okay, now we're going to look at some more of the moving things on a graph. So just to recap, first we're going to look at vertical translation. So just recall, adding or subtracting a number to a function will create a vertical translation or vertical shift. So for example, if you have your function and you add 6, then that moves the whole function f of x up by 6 units. Now, if you if your number here, your c value, is negative, then that's going to move your function f of x down by 6. Okay, just a little recap there. Now, if you're doing a horizontal translation, then it will look the other way. So if we see y equals f at x minus 2, that shifts the function 2 units to the right. And if you see f of x plus 2, then that's going to move you 2 units to the left. So this is just recall. So recap all the stuff I've been talking to you about today and that we looked at on Thursday and that you learned last year. Okay, so basically I just reminded you of that because I want to show you what that looks like on a graph. Just a few more examples, not just the simple y equals x squared. So here's the first example. So here we have f of x that I'm showing you. So that's what this, it's actually called a sinusoidal function. So this weird little squiggle, that's called f of x. So if I wanted you to graph f of x plus 3, then that would mean that I would want you to graph the same thing, except I would want you to apply this transformation, where the transformation is this plus 3. So ask yourself, is that A? Is it K? Is it D? Or is it C? Hopefully you can see it's the number tacked on the end, so that's a C change. So C changes cause a vertical shift, so that means our whole graph is going to move up by 3. So this is what it looks like. So wherever your point was, it moves up by 3. In the parent function, it gets moved up by 3. Parent function moves up by 3, parent function moves up by 3, parent function moves up by 3. So this is our new function, which is the same as the original, except with one transformation, which is a vertical shift up 3. Cool. Now the next one, so if this is your function, f of x, and the transformation that I want you to do is f of x plus 3, then you have to think, okay, so which transformation is this? Is it A? Is it K? Is it D? Or is it C? Because it's inside the brackets with the x, and it's being added, not multiplied or anything, that makes this D. Okay, so this is a horizontal shift. Because it says plus, we're actually going to move minus. Okay. So your graph will look like this. The same as the original, except moved over by 3. So all of the individual points have been moved over by 3 because that's what the transformation called us to do. All right, next one. This has 2 in 1. So here is our f of x, just a regular function. And now we have 2 transformations that are being requested of us. So are these A? Nope. K? Nope. K is the one being multiplied. D, okay, and C. So that means that we have a horizontal shift here with the 2 and a vertical shift here with the 3. So this horizontal shift is going to move which way? Awesome, left by 2. And this vertical shift is going to move which way? Awesome, down by 3. Cool. Hopefully you got that. So this is what your new function will look like. So you took your vertex, you moved it left by 2 because of your D value. So left by 2, and then down by 3 because of the C value. So we moved left by 2, down by 3. Now same with this point. Moves left by 2, down by 3. This point, left by 2, down by 3. This point, left by 2, down by 3. So do you see that for each individual point, I can apply my transformations? That's the easiest way to sort of handle transformations, to deal with one point at a time. Okay, so the thing is, if you try to do